Are you up to the maths lesson, Terminating and Recurring Decimals? In this video, I'll detail two important keys that will unlock this skill so that it helps you ace your exams. Beginning with the first key. Here you'll learn the fundamental difference between terminating and recurring decimals. This is best highlighted by two different music situations. Think of your favorite band or musician. Bonus points if you can guess the band in the picture. Now if we listen to a song they created, it will eventually end, or in other words, terminate. We call decimals that eventually end after a certain number of decimal places terminating decimals. So what are recurring decimals? Now think of this music situation. Have you ever stayed at a hotel with a fancy elevator? If you entered the elevator in the morning, you may hear something like this. Then if you entered later that afternoon, you would hear this. It's the same loop of music. This is exactly the same as recurring decimals. Recurring decimals have a digit or digits that repeat and continue and loop forever. Here are some examples. Since they continue forever, mathematicians created notation to communicate that a decimal is recurring. For instance, we write a dot on top of the digit or digits that loop. If there are 3 or more digits that loop, we add a dot to the start and end of the loop. If this video has been valuable, please hit the like button so it has a better chance to share to more people. Remember, decimals can be rewritten as fractions and vice versa. Now, if we were given the following fraction, how can we tell if it's either terminating or recurring decimals? The second key helps answer this question. Here you'll learn how to convert a fraction to a decimal, allowing us to identify if we are dealing with a terminating or recurring decimal. If we had the following fractions, the initial steps to convert to a decimal are the same. Remember, fractions are just division questions. So step 1, we set up the question in short division form. Then step 2, make the decimal point in the answer line up with the one in the question. Next, step 3, we complete the division as normal, add zeros to the end of the decimal if needed. Let's complete 3 divided by 5 first. Divide each digit at a time, answering first how many 5s go into 3, which is 0. Since we'll get a remainder, we add zeros to the end to complete the calculation. Then we carry the 3 to the next digit. Next, we answer how many 5s go into 30, which is 6, giving us a terminating decimal of 0.6. Now completing 1 divided by 3, answering how many 3s go into 1, which is 0. Since we'll get a remainder, we add zeros to the end so we can complete the calculation. Then we carry the 1 to the next digit, now answering how many 3s go into 10, which is 3 remainder 1. We carry the remainder to the next digit. Continuing, answering how many 3s go into 10, which is 3 remainder 1. Carry the remainder to the next digit. Notice, if we continue, the same pattern will also continue. Hence, this is a recurring decimal. Once you identify that it is a recurring decimal, we can rewrite it using the notation and we are done. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.